Alright, I'm going to implicitly differentiate in order to find the second derivative of 7y plus cosine y equals 2x to the fourth. Before I can find the second derivative, I first need to find the first derivative. So I am taking the derivative with respect to x. Okay, the derivative of 7y is 7. And then the derivative of y is dy dx. Plus, the derivative of cosine y is negative sine y. And I need another dy dx also because I also need the derivative of y. That's going to equal 8x cubed, and the derivative of x is dx dx. Now, I know that this is going to equal 1, and you don't really need to write it, but the reason I write it there is to remind you that every single time you have a variable, I have a y, I have a y, I have an x, you are going to take the derivative of that variable, because it's really common for people to forget the dy dx. So it just reminds you, every single time you have a variable, take the derivative of that variable. This is the rate of change of y with respect to x, which I get when I'm taking the derivative of y. And this is the rate of change of x with respect to the rate of change of x. Of course, that's a 1-to-1 ratio. Everything with a dy dx is on one side of the equation, which is how I want it. So now I'm going to factor out the dy dx, and I'll be left with 7 minus sine of y. And on the other side, I'm left with 8x cubed, because the dx dx is gone. Disappeared because it equals 1. Lastly, I'm going to isolate dy dx by dividing both sides by 7 minus sine y. And so I get that my first derivative is 8x cubed over 7 minus sine y. Alright, now I'm ready to take the second derivative, find the second derivative. So the second derivative the notation is d squared y dx squared for the second derivative. And I'm going to need to use the quotient rule because my first derivative is a quotient. So the quotient rule says the derivative equals the denominator, 7 minus sine y, times the derivative of the numerator, which is going to be 24x squared, and then of course the derivative of x is dx dx, minus the numerator times the derivative of the denominator, which is 0 minus the cosine of y. The derivative of sine is cosine, and then the derivative of y again, so I get a dy dx there. All of that divided by the denominator squared. So I'm just going to clean this up a little bit. So the second derivative equals 7 minus sine y 24x squared, and again this is going to equal 1, and over here I'm going to get a plus 8x cubed cosine y dy dx, all over the denominator squared again. Oops, I forgot the squared on the previous step. Add that back in there. Okay. We're almost done here. I'm just going to point out one more thing. It's all cleaned up, except I still have this dy dx here. Well, what is going to happen with that? I am going to plug my first derivative right in there. I know what dy dx is. I found it up here. So my second derivative now becomes 7 minus sine y, 24x squared, plus 8x cubed cosine y, and here comes my first derivative going in for dy dx. So that's going to be 8x cubed over 7 minus sine y. And again, all of that over my 7 minus sine y squared. Okay, I don't want to leave this complex fraction in here, so to get rid of the complex fraction, I'm going to multiply by its reciprocal in the form of the number 1. 7 minus sine y over 7 minus sine y. When I multiply that times my first term here, I'm going to get a 7 minus sine y squared. And when I multiply it times the second term, of course it's going to cancel with this fraction here, and then I will not have a complex fraction anymore. So, lastly, my second derivative is going to be 7 minus sine y squared times 24x squared, plus I'm going to combine my 8x cubes. I can multiply those together, and that's going to give me 64x to the 6th cosine y. And then, of course, this cancels that. And over my denominator, 7 minus sine y cubed, because when I multiply these two together, I add the exponents, and that's where the cubed comes from. And there we have the second derivative gotten using implicit differentiation, which of course we used because you could not solve for y in this equation.